Okay, welcome to this tutorial on ionic formula. We're going to go through how we write ionic formula. So first of all, let's have a think what we mean by formula. So formula of something is how the elements in a molecule are ordered. So for example, you've got the classic ones like NaCl, which has got sodium and chlorine in it. You've got things like MgCl2. You've got potassium iodide. So it's just basically how we write these things. Na2SO4. So that would be sodium sulfate. Sodium sulfate. So formula means these things. It means, how we put more than one element together. So in this tutorial, we're going to look at how we write those and how we put those things together. Now, these things basically act like a bit of a jigsaw puzzle. So that's how we're going to be thinking about it. But first of all, let's have a look at what we've got here. So you will be given this information in your GCSE exam at the back of the exam paper, along with the periodic table. So these are our ion tables. We got these ones in red over here and these ones in blue over here. The ones in red then, as you may have noticed, we've got things like H+, Na+, Ag+. Now, with the exception of hydrogen, all of these are metals. And if you have a look, each of them has got a charge on it, and all of these are positive. So these are all our positive ions. So if you're unsure what we mean by an ion, have a look back to the previous video on ions and ion formation and why we get these things with different charges on them, so plus charges and negative charges. So let's have a look at the blue ones over here. So we've got things like chloride, bromide, fluoride ions. Now all of these are non-metals. So you'd find those in the periodic table in the section along with all the other non-metals. That's how they're grouped. And if you have a look, charges on them are negative. So these are negative ions. All of these are negatives. You've got Cl minus, that should be a minus, you can't see it on there though. So Cl minus, Br minus, and so on. So recognizing the ones on the left are positive ions, the ones on the right are negative ions is a very important thing. So the important thing to remember about these two sets of ions is that some of them are positive. The ones on the left-hand side are positive, and like I said, the ones on the right are negative. And now kind of like what happens is these sort of behave a little bit like magnets in that opposite charges attract. So, for example, if you were to put a magnet with a positive terminal near a magnet with a negative terminal, you would find that they would be attracted to each other. Now, once the terminals of a magnet are together, it's very difficult to pull those apart again. So the forces are too strong, and so they form these very strong bonds. It's the same with ionic compounds. So we've got these positively charged ones over here on the left, these negatively charged ones over here on the right. And when they come together, they stick together with very strong electrostatic forces. So strong electrostatic forces. Now that strength of this bond we'll come back to later on when we're doing properties of ionic compounds, because this affects the properties of these compounds. So understanding this now it has knock-on effects for the rest of the stuff that we're going to do on ionic compounds. So understanding that then with how opposite charges attract and the formation of strong electric forces and bonds, let's take an example. So let's have a look here at sodium then. So let's have a look at sodium. Now if we look at sodium in our ion table, remember you'll be given these tables in the exam, you will see that sodium is Na, that's its symbol, which you can see in the periodic table, plus. So it forms Na plus. Now if we were to react that with chlorine, if you have a look here, the chloride ion is Cl minus. Na plus and Cl minus. Now, to understand what the formula is going to be for this, we need to understand how these charges are going to come together. So we're going to have the positive coming together with the negative, and they are going to cancel each other out. So the idea is to form, or the aim with ionic bonding, the aim is to form a neutral compound. So So those charges have to balance out. Charges must balance. So if we have a look at this then, we've got sodium and chlorine coming together then. And they form sodium chloride, NaCl. No, we don't write the charges now because this is a neutral compound. Now, if you look, if we, just for the sake of this, we put a 1 there and a 1 there. So we've got 1 plus, 1 minus. We do a little bit of maths here. So plus 1 minus 1 equals 0. And that is how it has a neutral charge. So when we're putting these ions together, the idea is to get this 0 charge overall. So let's have a look at a slightly more complicated example, because the problems come in when people have to put things together and they're like, well, how do I know if it's NaCl or if it's NaCl2 or NaCl3? And it comes down to the ions. So let's take a look at magnesium. So we're going to go down here, let's have a look at magnesium. So magnesium, from our ion table again, which is what you'll be given, there's a symbol Mg, 2 plus is the charge. Now again, let's react it with chlorine. So we're going to react magnesium with chlorine. Now chloride, as we said, Cl minus. Now, let's have a look at, this is where these charges come in important. Remember that we want to get a neutral atom. At the moment, if you were to take a stab in the dark and you were to guess now that the formula for magnesium chloride is going to be MgCl. Now, if that was the case, we would have plus 2, because that's over here, minus 1, which is there, which equals plus 1. But remember, we cannot have a charge. The idea is that we want to get a neutral atom. So we cannot have that. Cannot have it. So we need to balance out these charges. Now, if you think about it, if we've got 2 plus over here on the left, we've got minus 1 on this side. Now, to be able to balance them out, we've got to have another minus, haven't we? So let's put in another Cl minus. So we've got 2 of those now. So now over here, the overall charges then, we've got a 2 minus charge there now on the right, and we've got a 2 plus charge there. Again, if we do a little bit of basic maths, we'll find that plus 2 minus 2 equals 0. That's our all important neutrality there. So this must mean that the formula is going to be Mg, that's the symbol for it, and we've got 2 of these chlorines now, so it's going to be Cl2, because we've got 2 of them. Remember, the number is little and it goes down there, so you don't write it at the top like that or anything, so it goes down the bottom down there. So that's how we write the ionic formula of something like magnesium chloride. Let's take another simple example. Remember that the aim here is to form a neutral compound. That is our aim. So, and you could literally take any of these together. You know, so let's go with something a little bit more random. I'm just going to randomly pick something. So I'm going to go lead. Lead is Pb2+. I'm going to pick something random from here. Let's go for sulfide. Let's go S minus. So S minus. So I'm going to put a 1 there just for the sake of this video. So we've got 2 plus, 1 minus. So 2 minus 1 is going to give plus 1. So we don't want a charge, so we can't have this. We're going to have another sulfide ion. So now over here we've got an overall charge of 2 minus, and over here we've got an overall charge of 2 plus. So that's going to be right for this, isn't it? So the formula for lead sulfide then is going to be PbS2. Easy. Now it becomes slightly more complicated, but not very much more, when we look at groups. So I'm going to actually underline all of the groups now. So all of the things that I've underlined are groups. So for example, on the left we've got an ammonium ion, which is a nitrogen and a hydrogen, 4 hydrogens together, and that has a charge of +1. Over here on the right we've got hydroxide, which is OH, nitrate, which is NO3, sulfate, carbonate. If it ends in 8, that means that it has got oxygen in it as well. Okay, so nitrate, sulfate, carbonate have got oxygen as well. Now those groups we treat as the same as we were doing before. Okay, so we treat groups as one thing, as one ion. Okay, that's very important. So let's have a look at something. Let's have a look at an example of ones involving groups. So again, I'm going to pick some random, I'm going to go for copper 2. That 2 there in Roman numerals tells me the charge in it. So for example, copper 2 is 2 plus, iron 2 is 2 plus, iron 3 is 3 plus. So just, it's worth bearing those in mind, okay? But I'm going to go with copper. So I've got copper 2 plus on that side. I'm going to pick a group from the other side now, a group. So I'm going to go with, it doesn't really matter which one, let's go with nitrate. So we've got NO3 minus. Now again, you treat this whole thing, treat this group here as one thing. Okay, so overall that has got a charge of -1. Okay, so in order to form this, for these charges to balance out, that 2 plus, to balance out, we need an extra minus. So we're going to need another NO3 group, aren't we? Because only now have we got on the left we've got 2 plus charge, on the right now we've got 2 minus, because we've got 2 of them, there's one, there's another one. So the formula for this is going to be CuNO3, but because we've got 2 of these groups, 2 of them, we're going to put those in brackets, like that. And we're going to put a 2 out there, because we've got 2 of these groups, of these nitrate groups. So that is the formula for copper nitrate. Let's have a look at another one. So again, the key here is to treat the groups as one thing. So let's take an ammonium group here. So we're going to go NH4 plus. Again, you treat that as one thing. I'm going to try and make ammonium sulfide. So S2 minus. Oop, I should do that in blue really. So I'm keeping the color scheme just as a way of keeping it simple and things. So again, remember, we treat this as one thing, one big thing. At the moment, we've got an overall charge on the left of +1, and we've got 2 minus on the right. So for this to be able to come together, we're going to need another ammonium ion. So now we've got, overall, we've got a charge of 2 plus on this side. There's 1, there's 2, 2 plus. And we've got 2 minus on this side. So that's going to be neutral. 2 plus 2 minus equals 0. Okay, so we're going to have NH4 S, but remember we've got 2 of these NH4s, so we're going to put this in brackets, and we've got 2 of those. So ammonium sulfide, that's how we write ammonium sulfide. Comes together like a jigsaw. The final 2 examples that I'm going to do are actually from past paper questions as well. So, you know, just to show you how often they might actually ask these things. So the question that I'm actually looking at is from January 2013. Says or asks for the formula of lead nitrate. Lead nitrate. So let's have a look. We've got lead over here. There's lead. Lead is Pb2 plus. Nitrate over here on the right is NO3 NO3 minus. And remember, treat that as one thing. So in order for these charges to balance out, we're going to need 2 of these. Now we've got 2 plus on this side, 2 minus on this side. So the formula for lead nitrate is going to be Pb NO3, but we've got 2 of them. There's 1, there's 2. So that's going to have to go in brackets because we treat the group as a whole thing, and the 2 is out there. So that's an example of an actual past paper question. Let's take one more final example, and in this one it wants the formula for lithium sulfate. So again, easy as pie. These are like jigsaws. So lithium's on the left. We've got Li plus, and on the right for sulfate we've got SO4 2 minus. Now, obviously these charges are not going to balance out at the moment, are they? Because we'd have an overall negative charge if it was just LiSO4. We're going to need 2 lithium ions. So now we've got an overall charge on the left of 2 plus and an overall charge on the right of 2 minus. So for this, it's going to be Li2SO4. And that is the formula for lithium sulfate. So I hope that's cleared up any problems you may have had. So the key with ionic formula is to always go back to these tables, which will be in the exam paper for GCSE. Okay, so you don't need to learn those off by heart, you just need to know they're there. And then you can just slot them together like a jigsaw. Easy peasy.